Hey, welcome back to the unofficial Handmade Hero Mac OS platform layer tutorial series. My name is Ted, and today we are diving deep, building a programming or building a game engine with nothing but our raw fisticuffs here, and getting into some pretty exciting cross-platform things. So yesterday we did a pretty cool thing. We actually moved the sound over to the cross-platform layer. So this now, all of the sound generating that sine wave based on the controller input is now taking place actually inside of the game library. So we moved that bit out, and just kind of following along with the order and spirit of the series, the next item of business is to move all this controller logic out of the platform layer, or rather to have some concept of a cross-platform controller that the game is able to understand. So the game is going to take, just as the game takes a pointer, or two pointers rather, just as the game takes a pointer to this buffer, the display buffer, and to the sound buffer, it's going to take a pointer to some other thing. So some other kind of maybe we'll call it a game controller, right? So right, and this is so say something like a game controller, or maybe like a game input, something like that. I want to use exactly the same wording. The idea is that there's some kind of something that's like a game input. And so this thing is now going to also, in addition to taking buffer pointers, it's going to take something that's like a game input, right? So something like that, right? And the idea here is we're going to take this input from this kind of cross-platform concept, and then we're going to have the game library update the state of the game. So the state of the game will also start to reside inside of the game library itself. So our Mac platform layer is no longer going to be concerned with the actual state of the game. That's going to be something that the game library takes care of and handles, and only the game library really understands what the actual state of the game itself is. And so by state of the game, what do we mean by that? Well, right now, if we're really thinking about it, there's really, this technically does have some state, right? And so the state of this game right now, I would argue, is this offset X, right? And this offset Y. In Casey's, it's called blue offset, green offset. You can call it whatever you want. But all it is it's just this, the offset that allows us to, that moves this visual display buffer that we're looking at. So I'm going to say, you know what? Since the Mac platform layer no longer needs to care about these offsets, this is a game concept now, so let's just move it into the game, right? And so one quick way to do that is to make both of these a local persist, right? So we'll just do local persist in offset X. We'll just say that's 0 for now. And we'll do the same thing for the offset Y, right? And that's going to be set to 0, okay? And, okay, great. So now the game cares about this, right? And what we've effectively done just now is we've broken it because, this is no longer passed in from the platform layer. So what it means is that instead of the platform layer passing state as it was, right, it used to pass state to the cross-platform layer. Now it's just going to pass the controller input, the game input, the state of the controllers, and then inside the game library we're going to use those to figure out. We're going to use those to update the state of the game and then draw a picture, output sound, that kind of thing. So this idea of the other bits of what we could say are game state. This tone hertz is also that I would argue for now is a part of the game state. So that's going to go into, oops, I love Vim. Hey, I'm getting better at it. So that's going to go back into, that's going to go into the actual game library. So we're just going to set that to 0 as well. That's a local persist. All that means is that the values stay, the next time this game update and render function gets called, these values retain what their previous thing was. So they persist locally within the scope of that function. So, so they start off as 0, but then they're going to be kind of updated as the game runs. Okay, so now this game update and render function has really changed, because now instead of it just starting to take state from the game, it just takes this thing called a game input. And so getting into that, a game input, the way I really, there's a lot of different ways. First of all, I want to like kind of just clarify that there's like a lot of ways that you could do this if you wanted to, and I'm not going to tell you, what is the right way or what's not the right way. Again, the idea is to kind of be as much in the spirit of the series as I possibly can, and to give you a jumping off point that's as close to what actual Handmade Hero is, so you can follow the series. So we actually are going to use the exact same concepts that Casey uses, and in the exact same way. And so I have to kind of remember these because I'm not going totally off the top of my head. I'll probably reference code that I've used before. But we do have some concept of a game. It's like, oh yeah, so we'll call it a game controller input, right? Okay. And this game input, screw it. I'll just look at my other, because I don't want to be guessing and then have it be wrong, and that's just not going to be fun. So I was just working on this just now, so it's kind of fresh in my mind. So we've got this concept of a, yeah, so here we go. So game input is just, these controllers, right? So first of all, yeah, I'll just nab. I'll nab all of this stuff, because why not? All right. Okay, we're going to go back down. And I would also encourage you, when you watch these, definitely watch mine, but like I said, mine are kind of more meant as a supplement to this series. So it'll help you quite a bit if you also watch Casey's videos, because he'll kind of go more into the explanation as to why we're going with some of these. But basically the idea is a game input is we want the game to be able to support multiple controllers. So you could have this thing, support, gosh, as many controllers as somebody is plugging into their USB port or wirelessly or however it is that they're plugging something in. Right now, I wanted to simplify it because most of the series is like in one player, and it doesn't really ever seem that multiplayer is really ever supported, and so I just kind of felt like it's a bit of extra work to do multiplayer, and I figure most people just want to kind of get through this part and watch the rest of the series. So all I'm doing is I'm going to limit this to 2 controllers. The 2 controllers that we're going to have are the keyboard controller. The keyboard controller will always reside at the 0th index, and then the game controllers will be anything after that index. So that's kind of the idea with that. And a game controller input is really, so this is the cross-platform concept of game input, right? And so this notion of a game controller input, it has nothing to do with any particular platform. So controller input, say for my Sony PlayStation controller, goes through the Mac platform layer, uses the Mac-related IOHID library to sort of map the buttons and kind of do event watching to figure out when certain buttons get pressed, how the analog stick gets updated, all of those values. And then that information is processed, and it is then fed into this structure, this game controller input structure, which which then the game library takes. And so what I'm saying is this game controller input structure is going to be the same on every platform because it's this kind of cross-platform concept. And then every individual platform is responsible for filling in the values for this game controller input structure that then gets passed into the game library to figure out how to update the state. So this gets passed in on every frame. So every frame we're going to want to know at the start of this frame, what did we start out with as our x value? What did we start out with our y value? What was the minimum, the maximum, or yeah, the minimum x value, minimum y value, maximum x value, maximum y value. Actually, I don't know what the start x. Oh yeah. Right. Okay, yeah. So start x would be like at the start of the frame, what was it? And then at the end of the frame, what was it? And same with end. And then min and max were like throughout the process, through that frame. It's kind of as the input was being processed in that frame, what was the minimum x value and what was the maximum x value. We don't actually use a lot of these, and in fact, I don't believe that early on in the series many of these even get populated with values. But the idea is that we can, in fact, know a heck of a lot about what happened in terms of input over the course of an entire frame. So you can actually measure all of the button presses and all of the changes in state on the controller through a single frame. So a single frame could have people, maybe tapping the X button a bunch of times. So say, a frame is something like, if we're running at 30 frames a second, a frame is like 33.3 repeating milliseconds, whatever. And so that's kind of enough time, if you think about it. It's kind of enough time for people to kind of like mash a button really, really fast. And for some kinds of games, it may be important to know how many times somebody pressed that button during that very short frequency or very short period of time. Obviously, if you've got a faster frame rate, so if we're at 60 frames a second, then we're looking at measuring multiple button presses within a span of 16 milliseconds. So 16 thousandths of a second is a really, really tiny window of time to be measuring stuff, but even over the course of that small of a window of time, there's going to be like a minimum x value and maximum x value for the analog stick, all of these things. So the idea is that we kind of capture it all from whatever controller over the course of a frame, and then we feed that input into the game library itself, and we use that to then kind of update the state of the world or the state of the game, which we then use to draw a picture. And so if we're looking at this structure, okay, so we've got starts, and then we've also, so this is just the x and y coordinates and analog stick, because the analog stick is, remember, these are all in real 32, so floating point values for the analog stick, and the idea is that we've mapped the analog stick to a value between -1 and 1. You can see that in the previous tutorial videos, and what we're doing is like throughout the course of that frame, we're figuring out, okay, where did it start, where did it end, and we're going to save all of that. So that's just the x and y coordinates. Now, that's assuming that you're using the analog stick to control the character. We've got all the other buttons in there too. So this union struct, what is this? What that is it's what we're doing is we've got all of our buttons, and actually I'm gonna make that so it's uppercase. So we've got all of our buttons mapped into an array that I haven't done union structs that often, so I'm probably going to suck at explaining this. But basically the idea, as I understand it, is it kind of like flattens the contents of this buttons array. So this buttons array contains 10 values that are of this game button state structure type. And so all that we've done is we've just, we've got a single, so let me try that. So we've got up, down, left, right, A, B, X, Y. So each of these represents the state of all the buttons on the controller that we care about. And so each of these has a half transition count, and lets us know if it ended down at the end of the frame. And all we're doing is we're flattening that input into this game controller input structure, so that, let me go to, because I finished this earlier. Yeah, so that we can access it at, so here's an example of using that union structure, just so you understand a little bit. So I've got game controller input, star, input 1, and what this is doing is it's grabbing this is grabbing the PlayStation controller, because remember I said the PlayStation controller is going to be at the first index, or at index 1. Index 0 is going to be the keyboard controller. So this is keyboard controller. And then this is the PlayStation controller. I could even just call it PlayStation controller. That might. But I wanted to kind of not have sort of platformy knowledge or controllery knowledge in the game library. So anyway, so with this union struct, we've got, notice how the A button just got pulled all the way up to the top of the scope of that thing. So that's kind of what it does. So if I go back and actually, well, I guess we don't really care about what the name of this button's thing is. So what it's going to do is it's going to pull this button state up to this scope here. And I think really that's all just for kind of cleanliness. It's a little bit easier to read it that way, and so that's really the only reason that it's done that way. Is it's just kind of it's a nice way to just kind of pull all of this sort of compositional type stuff together into one big structure. So don't get too hung up on what this is. It's just kind of a fancy way, because there's all kinds of ways that you could do this. This is just like a fancy way of moving some of these things up into this like higher scope here. So that's right. It's just like a convenience thing. It's like now you can call up off of the struct. That's really it. There's nothing like special or magical going on there. So that's really all that is. And so what I kind of want to emphasize though is the game update and render is going to pass. It's going to pass this game input, and then it's kind of up to us to decide how to use that input to affect the state of the game. And so what I'm going to do is I'm actually just going to, since I've done this already, I'm just going to go and grab, I'm going to grab all of this stuff here and copy it over, right? And I'm just going to put this right here. So remember, so input 0, this is the keyboard input. So I'm just going to say keyboard input, just so people know. Okay, and then say this is the game controller input. It gets kind of confusing, and there really isn't any great way of handling any of this stuff, just because, like, yeah, I guess that's all I'll say is, you kind of, what I will say is, the purpose of this is not, again, the purpose of this early platform layer is not for you to be thinking about shipping a game. The purpose of this is to put you into a place where you can prototype whatever game idea you have. And so this is, if I can go on a bit of an sort of, what do you do when you entrepreneur things, right? So I have apps in the App Store, and that's what I do. And I actually got started. So here's an app that I made a while ago. This is my very first app. It's called Snow Dice. It's for snowboarders. Oh, oops. I didn't. No! Fucking Game Center. I should never have put that in there. Okay, so I don't want Game Center in there. So this is my very first app. It's for snowboarders. and it gives you like a random trick to try on jumps. It's kind of game-like. So what does it say? It says straight air, no grab. Okay, so it's on super easy mode, because if you're just going straight off a jump and not grabbing, that's like super easy. What do we have here? Front side, anti-spin, sailfish grab. Okay, so anyway, what I'm trying to impress upon you is this looks really polished, right? This is like the version of my app that's in the App Store that I am actually making money on right now. I make like some amount of money. Apple pays me some money every month for people buying these apps. Okay, well, so how did I get to that state, you might ask? How did I get to a place where I am selling apps in the App Store? I got there by doing really quick prototypes and proof of concepts first. So when I actually did my very first Snow Dice app a while back, I did the very first prototype with a language that I knew, which was, you know, kind of embarrassing because it was like JavaScript, or just like some total, you know, something I would just like take a crap on right now, that I would, you know, it was awful. It was like JavaScript, phone gap, like some horrible thing, right? But it was what I knew at the time, and I made the thing, and I very quickly prototyped it. And all I did was I was just kind of slamming out the idea. I was just kind of quickly getting the idea onto paper. I was doing a prototype thing. The intent was not to have a fully polished shipping thing. And then what I did is the next day I went onto the mountain snowboarding with my friends, and I showed my friends my thing that I made. And then my friend said, "Hey, that's really cool. Can I have it? Hey, that's awesome. Hey, that's a really interesting idea. Wow, that's great. I'm going to have so much fun with this." Okay, and so they went and I shit you not, you know, they played with that app or that game for a while, just in the like the grittiest, most you know, displeasing, you know, super prototype kind of thing. Okay, and so only later then, after kind of my friends, you know, took a look at it and were like really excited, and I got a bunch of people kind of, you know, stoked on the concept of the game first. Then we thought, okay, we need a graphic designer. We need to officially move to the Apple software development kits. We need to do all these more official things with this product, and then we need to do PR. We need to do all this. So only later then did we start to think about, you know, what we're going to do with respect to properly shipping the thing and asking for money for it. So there's a very similar thing that we're doing here. We're kind of waving our hands about some of this stuff, and I think that's okay. You know, we're saying, okay, well, does it really matter that we have full multiplayer support right now? Probably not. You know, probably not. Does it really matter if we're, you know, tracking like the minimum X, maximum X, start X? Probably not. Probably not. So the idea is, you know, what we're trying to do is we're just trying to, like, you know, give you something quick that you can use to kind of play and prototype with, and then, you know, later on, you know, once you have a prototype on your Mac or on any platform, once you've got a game, a thing with some gameplay that you can then show your friends, then you can start asking these more detailed questions. Like, then you can start asking this question about, oh, what do we do about the keyboard input? Like, how much is the keyboard really a part of this game? You know, is that something that we should even really care about here? And that's where you're going to make more of these decisions. But from like a prototyping perspective, this early on, it's foolish to try and you know, make these big sweeping decisions about how we're going to handle anything, because in all likelihood it's going to change, and you're better off just kind of racing towards something that you can put in front of people. You know, and arguably on some level, like I like making a game from scratch because there's, you know, because you can control it, and I feel like I can get more of the right like game feel, and like I just feel like I can get a lot more. I can make the experience better. But for your first rough prototype, maybe even, going so far as making a game from scratch might be, a little bit overkill. You may want to use an engine for that, just sort of knowing that you'll come back around and do it, properly. But that said, like, I also kind of agree with Casey in that, after he finishes this, he just stops and he's like, well, was that so hard? And I kind of think that's the case with like C programming. It's like, it seems really daunting. It seems like this huge endeavor to make a game engine from scratch. But actually, if you just sit down and do it, it's really not that bad. And you learn a lot, and you're still in a position where you can prototype things quickly. But then like you actually can take, the work that you spent on your prototype and you can really transition it into the product. So I'm not fully sure where I sit on that one, but I kind of don't think that this is all that hard to do. So anyway, so we're passing in our inputs. God, that was quite the digression. Sorry about that, but kind of an important thing. So anyway, we've got inputs, right? And we're using these. So we've got our game state, right? And so remember, it's kind of getting back to that concept of game update and render. Okay, this is doing all of that, right? So what is it doing? It's getting, we've got some game state, we've got some controller inputs, right? So we take the controller inputs, and then what we do is we use them to modify the state. So if the game controller's A button ended down, then I'm going to modify my Y offset a bit. And I'm going to modify, this is that same tone hertz thing where we were having the tone hertz, we're controlling the tone hertz from the speakers with the analog stick. This is the same thing, but all it's doing is it's using this game input that's passed in, right? So we update the state of the game, update the state of the world, and then after we update the state of the world, then we render gradient and sound. So now I think you're starting to see that game update and render is actually kind of doing what you want, what it says it's doing, right? So that's kind of the idea here. Okay, so we've got this concept of game inputs, right? And now we've also got this concept of game controller input. Great. But now we need to go back to the platform layer and start asking ourselves some questions about kind of where does all this stuff go. And so I kind of want to emphasize this idea of working backwards, right? And working from a very bottom-up kind of way. So the idea was we said, okay, we need to move controller input over to the game library. So we started there, right? And now that's going to have some ramifications on what goes on in this platform layer here. So we've got game update and render, right? And now that has changed, right? We changed what we're passing to it. And so it seems like what we need is something like a game input, right? Something like that. We've got our buffer. Remember, we got rid of offset X and offset Y. So let's look for offset X first, and I'm going to delete that, and then, yep. Okay, so all of this stuff right here, all this previous game state stuff that used to be in the platform layer is no longer in the platform layer, right? Because we've moved that state into the game, so we can just get rid of all this, right? So we got rid of that. We're going to keep this, because this actually, this has to do with mapping the analog stick input from the controller, and we actually will use this. Although we can get rid of the tone hertz thing, so we do care about map stick X because that's going to kind of tell us that map stick X is the same -1, +1 on the analog stick that we'll be passing into the game library. So we care about that. That's actual input that's going to go into the game. But the rest of this, like, offset Y, all that stuff, we don't need it anymore because the game library is now responsible for managing the state. So same thing with this offset X and offset Y. This is, for those who are unaware, this just to give you a little bit of context, we're now kind of towards the top of the main function. And so this is the setup. And so we had these up here, and now we're going to get rid of them. And same here with tone hertz, we're getting rid of that. That's not something that the game library really needs to consider or care about, or I'm sorry, that the platform layer really needs to consider or care about. So we're getting rid of offset Y, offset X, offset Y, sound. Okay, so we do want to pass a pointer to the sound buffer. We care about that. And then I'm going to get rid of this tone hertz. Okay, so we got game update and render, and now this takes the game input. And all right, so that means that somewhere we need to set one of those up, right? Like we care about doing that. So where would we do that? Well, I would argue we would want to do that in the actual platform code up towards where right after where we set up the game controllers. I'm going to do a little bit of cleanup. So just make a note to myself here. Set up game input here. Okay, so we're going to do that. So that's where we're going to set it. Actually, I'll do a to do. Okay. There were a few things that I noticed. Yeah. So this this latency sample count and target Q bytes, we can actually move that up to the sound code. So I'm just going to do that. I noticed that was a thing where it didn't really need to be happening every frame, so I just moved it. So anyway, that's kind of minor. Okay, so got that, and we got that set up. And so now one of the things that's a little bit different with this is we're going to want to make we're going to want to use two inputs. And the idea is, in order for us to figure out what the start values and end values were in a given frame, we need to know what the controllers were for what the controller was the previous frame. And so what that means is we're not just going to be using one of these game inputs. What we're going to do is we're going to use two of them. We're going to use a new input and an old input. And then we're going to swap them like every frame. And the idea with that is we want to, in order to figure out where something started and where it ended, we need to use the input from the previous frame to figure that out. So I'm just going to grab, let's see. This is from this platform layer. Okay. If I recall. Yeah, so we do this. So we've got two inputs here, right? And the new one is going to just reside at the first address, and the old one's going to reside at the second address. And we're going to use those. And then when we update, so whenever we update on every frame, we're going to just we're going to update the new input. So the new input is the one that's going to have our most recent controller input, like from the last frame, from whatever state it is, like right before we update the state of the world and render the frame. But we're also holding a pointer to this older input so we can compare the new input to it, and we can figure out the delta between it. So we can figure out the difference between what we did in the last frame and what we're now doing. But when it comes to updating and rendering, when we call this game update and render, we're actually going to pass the new input into that function. So That's kind of something that we're going to do. So we care about doing that. And got that set up. And so really, if we're thinking about it, kind of you want to ask this question of, okay, well, where do we update all of this stuff, right? And so I think we do it right before we update the sound. So I'm gonna go back down here, and yep. So, and this is just the code that's swapping those inputs, right? So we've got this this temp, which is the current one, and so this effectively swaps so it swaps them out, and so it's just kind of this is the changing of the guard that happens in every frame, and so we're saying, okay, so whatever new input, that's like what it was on the past frame. It's a little bit confusing, so this is like what it was, and then new input equals old input. Well, that doesn't this is kind of not super important because all we're doing is we're just like moving, we're just shuffling things through. So we're going to end up filling this new input with a bunch of new values anyway, and just kind of actually what this is doing is it's just copying. So it's copying what we used to have, and then if things change, we'll just overwrite it. And then old input equals temp. So what this is doing is it's saying the old input is now what we had before, like at the end of the last frame. So, and that's that makes a lot of sense, right? So whatever new input was gets swapped. Maybe this is a pretty common kind of pattern in programming, is this swapping things. We may end up making something a bit higher level out of this. We probably, but for now, we're not, just because I kind of rather keep things simple. And so now we kind of, what we want to do is we want to iterate over the Mac controllers. So remember, we've got this kind of, we got two concepts here. We've got a game controller input, and then on the platform side of things, we've got a Mac controller. And a Mac controller is that's the Mac specific concept of a game controller. And a game controller input is the cross-platform kind of concept of a game controller. And all we're doing is we're translating from one to the other. So we're translating from the Mac concept to the cross-platform concept. And so I think what we want to do is we want to go over the Mac controllers and then use those to update the cross-platform controllers. So we have this Mac controller index, and that's going to be 0. And then we're going to do Mac controller index less than 2. Since we're only going to have just the keyboard controller and the game controller, and then we're going to do Mac controller index ++. Okay, and so that's that. All right, not really sure what. So we're going to go over those two controllers. And so first of all, we probably would want to get the current Mac controller. So I think it's Mac game controller star, Mac controller, and then that's just so. We don't actually have that yet, right? So we need this array of Mac controllers that we're going to go over. We have the two Mac controllers up here. So let's see. I've got this Mac. So I've got the two Mac controllers, and remember, we're going to get rid of this game controller concept here. So we're done with that. So I've got the keyboard controller and I've got the PlayStation controller, right? What I want to do is I want to make an array of pointers to those two controllers. So we're going to call that thing, we'll call it Mac controller star Mac controllers. And then that's got 2 in it, right? And then with this sort of structure, like array constructor thingy, we can just put the different controllers in there. So we can go keyboard controller, right? And since it's an array of pointers, we have to make sure that it's the address. So the @ symbol that says, take the thing, make it a pointer. So we're gonna do that, and then we'll take the PlayStation controller. And again, you can call it PlayStation controller if you want. I just call it that. You can call it game controller if you want. Really doesn't fully matter. But the idea is just whatever your actual game controller is. So now we've got our Mac controllers. So we're going to use that. And then down here we've got Mac game controller, star Mac controller. So now we can just say Mac controllers at Mac controller index, right? And that should just work because this is a pointer to a Mac controller. And then what we want to do is we want to get the old game controller, the old game controller from the previous frame, and the new game controller, so from this frame. So game controller input. Let's see. Game controller input. So we'll call this new input. I forget. I just want to remember what I actually call it so that I'm not consistent. Okay, yeah, old controller, new controller, right? All right. So I'm just going to paste those in because again, the advantage of me doing these videos as opposed to a live stream is I can just copy code. So we get the old controller. The old controller is from the old input, right? It has every one of these game controller, every one of these game input things has a controllers array. Remember, so every one of these game. So we're holding on to a fairly big structure here because the old input has both the keyboard and the PlayStation controller state in there, and then the new input has both the keyboard controller and the PlayStation controller state in there, right? So that's kind of what we're doing, and so and it's going to be at that same controller index. So on the first iteration through the loop, we're going to go through the keyboard controller, and then the second iteration, we're going to go through the actual game controller. So kind of a lot going on, but this all gets updated pretty quickly, and we're not really caring about performance right now, so I wouldn't make a big deal out of it. So we got our Mac controller, and so now, all right, so we're going over the stuff, right, and then we're going to pass it as the new input. So this is actually where we would need to, update game controller, right? So update game controller inputs, right? And so there's a few things that we're going to want to do. One of those is we want to, update just button state, right? So what's that look like? And I'm actually going to, again, I get to cheat. So I'm going to grab some code from this here. So processing the game controller button state. So we're going to grab this, and we're going to use that. And that can just go straight above your main function. Oops. Okay. All right. And so this will just update one of the buttons. And so what we're going to do is we're going to pass one of these game button state pointers. We're going to pass the old button, the state from the old controller, and the state from the new controller. And then is down is actually, that just represents what the state of the Mac game controller is right now. So this is the new is down. Actually, I'm going to call that what that is. That's the new is down, right? And so, if the new state ended down, then that's based on the new is down, right? And then you can do these, the number of transitions that happened. Half transition count, Right now we're not being super, well, I guess we are being kind of fancy. I think the idea is that we'll be able to update this. We'll be able to do more. We're not doing anything with this half transition count. So there's a little bit of thinking kind of forward that is maybe not necessary, but because right now all we really care about is this like ended down. But a half so whenever this thing gets called, it's going to update the number of times somebody pressed a button. So like half transitions. A half transition is just, did it go from down to up or up to down? And so like you want to know how many times that happened in a given frame. Especially for like these really kind of twitchy games, like a fighting game. If your game is one of those kind of games, you're going to care about that kind of thing, right? So, so what's this doing? So first of all, pass a pointer to this new button state, and then so we're going to update whether it ended down, right? And then this half transition count. So if this is like how many did it transition or not from the old state. If they were the same, then we're not going to transition. But if it was different, then we're going to add one. So it's a little bit, maybe a bit fancy for now, but probably a good thing to have. So we're going to take that function here, and we're going to just paste it back in here where we're going to update the controller inputs. What we want to do is we want to update those like for every button that we care about. So okay, so this game button state. So remember, this is kind of getting into our structure here. Remember, we've actually broken this thing down into all this different state, right? And so because this is like this union structure, the game controller input, this button, this up state actually exists at the scope of that struct at the highest, at the top level scope, and so does the down, and so does the left and right. Okay, so all of these exist at this scope. So what we ought to be able to do is just go, old controller. Wait, and that's, I want to say it's something like that. Old controller A, right? Hang on, I gotta remember. This is, like I said, I didn't really, okay, yeah, so we want the address of it. We don't just want the, okay, gotcha. So we want the address of the old controller A, and then the address of the new controller A. That makes sense. And then the new is down is actually just on the Mac controller. And remember, I use the PlayStation controller. And so what's the new is down going to be for me? That's like Mac controller. I forget if A is, I think that's like circle button, right? I think that maps. If I like look at like, a Super Nintendo controller or something. Okay. Yeah, so clearly the yeah, so A definitely maps to circle from a PlayStation. So just in case you never played Super Nintendo and were deprived of a real childhood, there you go. So that's so this is just going to update what this is doing is we're updating our new controller, right? So if I go back to this function, we're really updating the new state. So, we're passing in a pointer to the old state. We're also passing a pointer to the new state. But the new state, the new input is the only thing that's actually getting updated here. So we're just using the old state to determine how we're going to update it. Anyway, going back, Right. So yeah, going back here. And then, you know, the new thing that we're passing in is from our Mac controller. So what this is doing is it's mapping the input from the from the platform specific stuff, right, the Mac, to the cross-platform stuff, the cross-platform game controller concept. So that's the idea, right? And every platform layer is going to have to do something like this, right? So we got that. Okay, now we care about B, right? What's B? B on mine is the X button, okay? And remember, you can do this however you want. You've probably got a different controller, and so you'll probably do it differently. So X, now, I forget. This is like pathetic that I don't remember. Okay, yeah, so there's where X is on a SNES. All right, so that's the triangle button for me. Okay, and then Y. Y is the square button for me. All right, so that gets our buttons updated. Okay. Now, we've also got the D-pad, right? And the D-pad is a kind of button. And I played around with this a little bit, but what we more or less want to do is we want to do something similar here, but for you know, right, left, up, and down, right? So that's our D-pad input for this cross-platform controller. So if I'm looking at this, like right, okay, right. And the reason we can do that, again, is the magic of union structs. Because remember, we've got up, down, left, right. These are all a part of that union struct. And so they're mapped at the scope of this game controller input. Kind of cool. So what are we going to pass from our Mac controller? Well, remember that, let's see, maybe I'll open that up just so we can look at that Mac controller concept. So remember that it's the D-pad. Oh, and I guess I also need to do shoulder buttons. All right, let's do that first. Hang on, shouldn't be a big deal. So it's like left shoulder button. What did we call it again? Yeah, just left shoulder, right shoulder. Okay. So left shoulder. And I think we just called that, yeah, left shoulder button state. I'm just going to close this real quick because it's ugly. Would you like to see the magic of Vim? So 554 to 556, replace left with right, G. Cool. So that's just a quick kind of thing you can do. Search and replace from your command line. So we replaced, yeah, right and left. So there's the shoulder buttons. Okay, getting back to it now. So now we care about up, down, left, and right. But what you'll notice is that instead what we've got are just D-pad X and D-pad Y. And now that's not really a Boolean value, it's an integer. And so you know, if we're thinking about this, we've got this integer. So again, -1 is like let's just say X, right? I'm just kind of thinking here, X, right? So -1 is going to be like left, and then 0 is going to be neutral, nothing, and then right is going to be 1, right? And then I think on Y it's something like, Y is a little bit weird because like -1 is up, and yeah, and then 0 is nothing, and then 1 is down, I want to say. So the y-axis is actually inverted, and this is something where we're gonna talk about that later. It's a bit of an annoyance, and what we actually want later. This isn't something you'll get from me. This is something you'll get from Casey. But what he ends up doing is he ends up like flipping the coordinate system in the game so that physics is like more intuitive, which makes a hell of a lot of sense. So anyway, so if we get thinking about this, we are going to update the right button, right? And what are we going to put in there? Well, it's right is only going to be true if it's 1, right? So something like, you know, bool 32 right equals Mac controller dot dpad x like greater than 0, right? So if it's greater than, I'm using a ternary expression here. There are pros and cons of ternary expressions. Pro, very quick expressiveness. Con, sometimes if you have too many of them, it can be difficult to debug. I'm not necessarily for or against them, but there are just times where it makes sense to like break up a ternary because it can be a pain in the butt to look at it in the debugger. Quick aside. So if that's greater than 0, then we return true, otherwise false, right? Quick ternary expression. And then all we're going to do is we're just going to pass this right into here. And so there's that. That's just kind of, so you can kind of see how if it's, for any other value, we're going to pass 0 for right on this Mac game, on this, on the actual game controller kind of concept. And just because I don't like to like waste much time, and I'm sure you know we've been at this for like an hour, so all I'm gonna do is just like, you know, showing you what we're doing here, and really we just do the same thing for all the other ones. So I'm just gonna come back and replace all of this with this, and get rid of my comments so you understand kind of what the concept is. So got right, left, up, and down, and if x is less than 0, then we are going left, and if y is greater than 0, then we're going up. Yeah, greater than 0? Maybe I did get that wrong. Less than 0, no. Either way, I know that this works. We can tweak it later if there's a problem. So yeah, so we're just passing these Boolean values as to whether we should say that we're going right or left, etc. And that all comes from the Mac controller, so we're updating that. Now, and really my goal for this video is not to, we'll do a little bit more cleanup later, like on the next one, but yeah. I'll leave it at that, you know, and there's going to be a whole cleanup pass that we're going to do on all this stuff. So we'll just have a bunch of to-dos that we'll kind of rifle through. So next, we want to handle like the analog stick, right? And so great thing here, is there something? There might be something that I missed in this. Is we've already got this kind of concept of the mapped thumbstick X. So we're just going to grab that from the bottom here. So we actually are going to use that. Okay. And we also have this concept of, you know, we have this is analog thing. And we're just, for now, just to make things easy, we're going to assume that our game controller inputs are analog, all of them, even the keyboard, just because don't really want to deal with that yet, so we'll say that, and I'll make a little to-do. And I think we already know about this mapping, so I can get rid of that. Figure out if controller really is analog. Okay. And this map stick X, actually what we're going to do is we're just going to say, okay, well, new controller dot, the new controller's end X. So new control, oops, not what I wanted. It's the joys of Vim. New controller end X is the left thumbstick, is this mapped value for the left thumbstick. And remember, we have all these things that we can do, but since we're just prototyping, we're not necessarily using all of the different inputs. So we're using some of them. We're just using the end X, and similarly with like the end Y. So just left thumbstick Y, right? So now we've got those, and I want to say, I'm hoping I don't forget anything else. Well, I guess we did use the start. Oh, okay, yeah. That's right. So the start is just what the old controller, the start at the new controller is whatever the old controller was, which makes sense. So we got that, and we just do that right here. So this is, you know, that bit. And do we do anything with, I forget if we do anything with like maximum and minimum. Okay. And so another kind of cool thing too is just know what I would like to impress upon you in these brief moments that we have together. I would like to impress upon you just how much of this is actually quite similar to the PC platform layer. And like this is really almost identical in a lot of respects. It's a little bit Mac specific, but there's really a lot of concepts that have been borrowed over from the PC. And so if you're, you know, remember, I had some resources available to me when I figured out how to put this thing together, but a lot of it was like looking at Casey's videos, looking at other repositories, following along, trying to do it myself. But honestly, if you think that this is like really hard to do, it was a bit of a challenge for me, but ultimately a lot of the stuff is the same, and a lot of the resources that you use, you know, much of what you're going to do is going to basically amount to a very similar thing. And I might also add that if you go back to my very first video, I came into it kind of noobish because I didn't really know much. Like I didn't know how to do much like straight C programming, and so I was like thinking that we would use all these like Cocoa APIs. I came in all like green and excited, and I would say, oh yeah, we'll use all this Apple stuff. And notice like it's funny. It's actually funny because and there, you know, maybe there's like people that are more like Apple programmers who would, you know, charge me with heresy. But like we really have not used much Cocoa at all. Like, we've used a very very small amount of Cocoa. You know, we only the areas where we have to like work with these kind of object-oriented system APIs, like the window. You know, like the window is this object-oriented thing, so we kind of have to like follow the object-oriented rules. But you know, pretty much everything else, like a lot of the other stuff, is like one of the kind of cool things about Objective-C is it's fairly, at least like the much older school kind of Objective-C, is it's fairly opt-in. And by that I mean, when it was originally conceived of, it was actually meant to be like a really light sort of object-oriented layer on top of like all this procedural stuff. And only sort of like through the course of cultural evolution over time have people started to think, have people like started to like flip the table around, and you know, now like we start from the object-oriented thing and the procedural thing is the scary thing that we don't want to touch. But guess what? I'm showing you that you can actually do this on a Mac in this like totally procedural. You can really do like the minimum amount of object-oriented stuff, or just kind of like, you know, make a choice about how much stuff you want to be object-oriented or not. It's really, you actually really do have a choice here as to how you want to approach this. So anyway, that's my second long tangent of this session. So and again, you know, because my idea was to try and be as in the spirit of this as I possibly could. And if I was, if I'm looking at actual Handmade Hero, much of it is in this like very procedural style. And so I opted to go with that because that really is the style of it. So now I'm thinking, where are we? So we're at, it's entirely feasible right now that we can build and run. And I'm going to try doing that. Okay. I knew there was going to be some problems. Okay. Unknown type Mac controller. Okay, so that error. Okay, so let's see. We can get that. And that's simple. That's because, you know, it's not just a Mac controller, it's a Mac game controller. So I'm sure we'll have solved that particular error. And then this is, remember, we want to use Mac controller for this, not game controller. Game controller was this old concept that we had earlier that we're actually replacing. So I'm going to go to 582. And I know that there's a much better way to do Vim than what's it, Tim Pope or whatever has like this cool thing where where I don't have to know what the lines are. So when you're dealing with files that have like multiple hundreds of lines, it's kind of nice. So there's that, Mac controller, and Mac controller star. Oh, that's a note. Okay. Let's try and build that again. All right, so it builds. It builds, but will it run? That's the question. So we've got this. Okay. I hear my tone. Okay, so the analog stick part's working really quite well. And then what I'm doing is I'm pressing right on the controller, and that's moving the buffer, and I'm pressing left, and it's moving the buffer, and I'm pressing up, and it's moving the buffer, and I'm pressing down, and I think I've got a few. So circle also does. I think circle we map to A, right? All right. Well, my friends, we are what, an hour and 7 in to making this thing have cross-platform sound output. Okay, so that's pretty darn cool. And kind of what I'm wondering is, do we have any to-dos or anything that we like? I don't want to spend too much more time today, just because I feel like an hour is kind of a long time, and you know, people will want to grab a snack or something. So, where's this? Oh yeah, that's my experimental folder. Okay, let's see. Also, by the way, you know, at the end of Casey's streams, he usually does. He's got people asking questions and stuff, and I just want you to know that you can ask me a question and send it to me as an email, or you can you know, send me a GitHub message or something like that. Let's see. Okay, yeah. So we've got that. You know, there were a few things that we maybe wanted to do, but you know, outside of a few to-dos. Okay, so this to-do, and I think what we will eventually go over kind of a cleanup thing, and that, you know, that'll be nice. So I'm gonna put a to-do in here as well, saying like to-do. Have a way to specify if it's analog. That's more of a cleanup thing. I kind of want to just, like, you know, for some days where there's going to be kind of a lot of to-dos that we have that we're going to want to clean up, we'll just sort of do those all at once, and that'll be that. And then I'm just kind of looking over this, but you know, overall, I'm pretty happy with where we are. We haven't really tested the keyboard again, So we'll just test that that does what we wanted. Test this again. But overall, you know, we've got cross-platform game controller input that is in the same. It's done in the same way. Okay. Yeah. Yeah. It's done roughly in the same way and in the same spirit as actual Handmade Hero. So, where do we go next? I think the next item on the agenda is proper VSync. I think could be wrong, but the idea is, or maybe it's it might be cross-platform. Yeah, that's right. It's cross-platform file I/O. So what we're going to do is we're going to have a way for the game to ask the platform, because sometimes, not always. Remember what the sort of underlying idea here, how we're thinking about this. We're thinking about the game as a service that is provided to the platform. However, there are some circumstances in which the platform needs to provide something to the game. And one of those circumstances is file I/O. So one of the things you're going to need to do pretty early on is load bitmaps. So if I got like an animated character kind of moving around the screen, I need to load that character's bitmap on whatever platform I happen to be on. And so we want to set up, it's not going to be the full shipping file I/O, it's going to be like a debug file I/O. And it's just enough file I/O for us to be able to load a bitmap of some, like a character or like maybe some sound on this platform. Again, not necessarily going to be the most robust version, but just good enough to be able to get some bitmaps on the screen. So that's kind of the next thing, is we're gonna come up with a way to have the game library call back to the platform, and then have the platform, you know, on this again. You know, we could use NS File Manager, but we're not, because we're actually going to go totally procedural here and not use any OO stuff. We're going to use like fopen and some of the Berkeley software distribution functions that come with Mac OS. So we're going to use some of those C functions to load files, and that's going to be pretty cool. So stay tuned for that. And yeah, it's Friday over here, so have a good weekend. A few things I always kind of note at the end of every episode. Absolutely go and buy Handmade Hero. It's only $15. It's worth following. You're gonna learn a ton of stuff. Probably for me, in terms of like, you know, the return on investment for my own programming career has been like multiple fold. So very valuable learning experience and tool, especially if you're just starting out programming. Really highly recommend it. There's GitHub repository links that are below, so you can follow this. I have two repositories. One is for the video series, and another one is actually the full platform layer that I did. I suspect now that I'm going over this a second time, I would gather that the video one is going to be better eventually, because it's a little more polished. I've had a little more time for the concepts to kind of like marinate in my brain, and for me to think a little bit more about, now that I have a better understanding, I'm thinking a little bit more about how I really want to do a platform layer. And so I suspect eventually it'll be more polished, but there is kind of another one that's like the full thing if you just want to like plow ahead, which you may want to do. And I do have a Patreon. I would appreciate if you support it. Like the video, subscribe, share with your friends or anybody that's interested in making games who has a Mac. And I will see you next time.